All right, so let's see if we can work these out. Given the graphs, we want to find any slopes and areas under the curve, and we want to indicate what quantity each slope means and area corresponds to, and give units. Okay, so I'm going to start with this section here, and I'm going to say this slope there, since this is a velocity graph, this slope's going to be our acceleration, and looks like it's going to be positive 3 meters per second divided by 8 seconds. So that's going to be our acceleration. It's a positive acceleration. Over here, we're talking about a negative 3 meter per second, and that's going to happen over 3 seconds. So that's going to be a negative 1 meter per second per 1 second acceleration. And that's this slope here, the second period. Then I suppose we want to find this area right here. This is a triangle. So, and since this is a velocity graph, the area is going to be our displacement, which has direction to it. So it's going to be 1/2. Final velocity looks like it's 3 meters per second right there. So 3 meters per second times 8 seconds. So that's going to be 4 times 3, which is 12 meters. So that's this green triangle. Then we have this blue triangle here. So that's going to be the second displacement, which is going to be 1/2, and again 3 meters per second height, and that's for 3 seconds. So this is basically half of 9, which is 4.5 meters. So we have 2 displacements. So it looks like the overall displacement from beginning to end is 16.5 meters. So the final position of the object minus the beginning position of the object is 16.5 meters. In other words, the object changed its position in the positive direction by about 16.5 meters. So that's your first example. Now I'm going to move on to the next page. I'm going to do the same thing again. So next page, looks like I have a constant velocity in the beginning. So there's acceleration is 0. So for this section, the acceleration is 0. Since my velocity is constant, there's no change in velocity. My displacement is going to be this area there. So displacement is going to be just 1.5 meters per second times my 7 seconds. And let's see what that is real quick. What is it? 1.5 times 7. So 1.5 times 7 going to be 10.5. So 10.5 meters. That's my displacement. That's the overall change in position in the first 7 seconds. And it's a positive value. Okay. Looks like I have an acceleration and from 7 to 18 seconds. So that acceleration, this number looks like negative 2 meters per second. So my change from negative 2 meters per second to 0 is going to be 0 minus negative 2 meters per second. So that means my change is positive 2 meters per second. And I have a positive slope there. So from 7 to 18 seconds is going to be about 11 seconds, I'm thinking. 18 minus 7 should be 11. So this happens over 11 seconds. So let's see what that gives me, an acceleration of, 2 divided by 11.18. That means I have an acceleration of 0.18 meters per second per 1 second. This is a positive acceleration because my slope is positive. Finally, let's find this area here. So that's going to be a displacement since this is a velocity time graph. And it's a triangle, so it's going to be 1/2 negative 2 meters per second times 11 seconds. Okay, let's see what that's going to be. So 0.5, right, times 2 times 11, and my answer is going to be negative. Let me try that again. Oh, it's going to be 11. That's correct. So that means my displacement is going to be negative 11 meters. So my object changed position in the last 11 seconds by negative 11 meters. So overall displacement looks like 10.5 meters positive direction, negative 11 meters, and then that's 11 meters in the negative direction. So my overall displacement is going to be negative 0.5 meters. So the object moved in the positive direction 10.5 meters, then it moved 11 meters in the negative direction. So from start to finish overall, the object is about 1/2 meter in the negative direction away from where it started. Okay? Let's do one more. Now we have an acceleration time graph. That's interesting. It's pretty cool. This first area, this area here, since it's an acceleration time graph, the area under an acceleration graph is going to be our change in velocity. And it looks like 1.1 meters per second times 10 seconds is going to give me 11 meters per second. So our velocity changed by positive 11 meters per second in the first 10 seconds. Okay? In the last 10 seconds, our object changed velocity by a different amount. It's negative 0.7 meters per second times 10 seconds. And this gives me negative 7 meters per second. So in the last 10 seconds, our object changed velocity by negative 7 meters per second. So let's wrap our brain around this. Our object moves in the positive direction. Sorry, I said that wrong. Our object changed velocity by 11 meters per second. And the velocity increased. Went from some number, and then it add velocity to that number. So the change in velocity in the first 10 seconds was a positive 11 meters per second. The change in velocity in the last 10 seconds was negative 7 meters per second. So overall overall change in velocity from start to finish, from 0 to 20 seconds, is going to be like positive 3 meters per second. That's our change in velocity overall. Anyway, hope that helps. Those are some practice problems. Thanks for watching. Have a good day.